My buddy Drew over at Fisher's shop recently did a video about a dust collection adapter that he made for his new miter saw. Using some highly scientific calculations, he proved that it was an impressively effective alteration. The only flaw he claimed with his design is that it only works when cross-cutting boards at 90 degrees, and it would have to be removed to do any angled cutting. I loved his idea and immediately started pondering on what my solution would be for this interesting problem. I decided that rather than make an adapter that would blend in with the existing fence like Drew did, I was going to remove the fence entirely and make an all-new one of my own with the dust collection built into it. I hypothesized that I could make a fence out of a series of pieces all stacked together like a loaf of bread, and each different piece would serve a different function in the overall fence. Since my mind mostly works in 2D, I started out by drawing each of these pieces flat in Adobe Illustrator to get them out of my brain and on paper. Next, since I'm trying to learn 3D modeling to get my old brain to function with modern technology, I redrew all of the pieces in Fusion 360, extruded them, and stacked them together. Convinced that my design would work, I put my X-Carve to work cutting out all 42 individual pieces that would make up my new fence. It would be possible to cut out these pieces without a CNC machine, and in fact I have plans available that include scale templates so you could do just that. But with this many components and my desire for precision, the X-Carve was the perfect tool to cut out all these nearly identical parts. Not to mention it allowed me to step away and work on other projects, only checking in periodically on the 2.5-hour carve.
Alright guys, now obviously I'm telling this story a little bit out of order. Normally you would want to understand the concept before you go straight into the build portion, but I figured it'd be a lot easier to explain my theory behind all of this with the individual pieces in hand rather than trying to cut them out and explain it all at the same time. So this whole fence is made up of about 40 individual pieces, but there's actually only about 10 different pieces inside of it. So you've just got multiple different numbers. You can see I've got it numbered and we're going to walk through those. My hope for this also would be that it's fairly modular. So if you wanted to make one for yourself, you kind of measure your own saw. I don't have much experience with other saws, so I don't know how well it goes together, but I think you could adapt it to that where instead of having 1 through 10, maybe you only need the first 6 pieces and then you just stack them together differently, or you make it as long as you want to. And so this is still part of the trial and error process, but I'm going to explain the thought process and then we'll keep moving. So we're going to start with number ones. I've got 2 number ones and all they are is a 3.5 by 3.5 inch square with a 2.5 inch circle cut out of it. So this fits standard shop vac type attachments. I curved the back end so that the saw had a little bit more clearance on the back side. I beveled this bottom corner so that the dust could get in there and not mess up your cuts when you're actually cutting. I cut out this notch for T-track so that on shorter cuts the stop block would actually be in the fence. Beyond this, it's going to be in the table of the bench, which is going to be another video. And then I've got 2 different, basically, indexing holes, and that continues through the entire thing. The radius on the back, the bevel, and those indexing holes continue through this entire thing so that you can try to keep it aligned easier when you go to the glue up. Now 2 is almost exactly the same thing, but that 2.5 inch circle starts to get squished. Parts number 3, same thing, squished a little bit more. Parts number 4, which is this whole section, has this part cut out. Now, it'll make sense again in a little bit, but that's actually where the fence will connect to my miter saw. Again, I don't know about other people's miter saws, but we'll look into that later. Number 5 is the same as number 4, except it doesn't have that cut out anymore. You know, at this point, we have finished squishing that circle as far as we're going to get it to, and when we get to number 6, I'll show you why we squished the circle rather than just keeping it round all the way through. So 4 and 5 are the same except for the cutout on the bottom to attach it to the saw. We get to 6 and that's where the magic starts to happen. I would credit this sort of idea from Frank Howarth. That's kind of where I had the thought of, well, let's give it a bunch of vent holes while it still has a flat face. So that should be able to pull a lot of dust through it. And if you look, it's actually about a 8 inch, 7.5 inch chunk that's going to have that much ability to draw dust in through it. And then when you get to 7, you actually have the open cavity because most dust is going straight back from the blade. There are 2 1/4-inch spacers in here, and the only reason for that is kind of superficial. I didn't like the look of these teeth coming next to this gap. 7, as you saw, is just the complete cutout. Then we go back to some 6s, and then another one of those. And the reason for the other 1/4-inch thick piece, I've been calling this 6.5. The reason for that is to keep the spacing the same. This line right here is the exact center. There's 15 1/4 inches this side, there's 15 1/4 inches this side. If I didn't have this one, it'd be off by 1/4 because of this one. So beyond that, you get to 8, which is just a block, which is just a stopper. It's got the indexing holes, the same shape, the same T-track, but there's no reason for the airflow to continue because all the work is being done here and going out that side. Now this is also set up because of the way my shop is going to be. I'm going to have the dust collection pulling out the left. If you were going to try to make this for yourself and you wanted it to come out the right, you just move it to the right. If you thought you wanted it to come out the back, well, you wouldn't have to have any of these have holes in them. You could just make your own hole in the back here. There's lots of different options. So those are 8s. 9, now we have a different sort of shape here. The reason for that is I thought if this is going to be a whole solid block, it's kind of a wasted space. I toyed with the idea of compartments with doors and lids and hinges and stuff. And I thought, you know what, let's just cut a channel in it and you can store pencils and rulers and tape measures and stuff in there. 10 is the same as 9, but again, we've got this tab cut out so that it can connect to the saw. We go through a bunch of 10s, we go back to 9s, which are the same thing, and then I just capped it off with a couple of 8s to get it to the same length. So I realized that was kind of long-winded, and I'm hoping that it made a lot more sense as to why there's so many different pieces into it now. So here's kind of a close-up look of how those first 4 pieces transition in shape from a 2.5-inch circle to more of a squished piece. The squished channel allows for a lot more material here to add some strength to those tabs, and you can kind of see how the airflow would change by transitioning from one to the next, and there's more material here than there is here. It's the whole reason for changing the shape, and now that transition takes place over 2 pieces per step. So there's 2 1s, 2 2s, 2 3s, a couple of 4s, and then after that they're all the same. But as we move on like that, I'm going to go ahead and sand these ridges on the inside to ease that transition through and hopefully make the airflow go a little bit stronger.
I found that the easiest and fastest way to do the glue up was to dip one face of each piece into a tray of glue, then slide them down over the indexing dowels. In an effort to keep everything in perfect alignment, I would sandwich the sections between 2 straight edges and reference the bottom on my workbench before squishing the whole thing together lengthwise. The initial glue up was done in 3 chunks, the left side, the right side, and the middle section. Then I did a final glue up to connect those 3 pieces together. After a night of drying, I got to pull the full fence out of the clamps, and I was really excited that all the steps I took to keep things lined up and flush had paid off. The front and bottom faces are the only ones that really mattered, and they came out in great shape, and there was barely any noticeable bow from one end to the other. A few light passes over the joiner should make it perfect.
Alright guys, here's the story so far. Now, I know that MDF is soft, and so that was part of the reason why I chose it, to make it really easy to cut out on the CNC machine. And I thought by taking tiny, tiny little passes over my helical head joiner, I'd be able to sort of true up these faces without causing any problems. And I haven't caused problems yet, but it is chewing away the MDF more than I was really hoping it would, even though I was taking tiny little cuts. So I think to get ahead of it, to keep anything bad from happening to this now pretty intensive workpiece, I'm going to use some penetrating epoxy and just kind of coat the whole thing in it and let it sit here and harden. And if it doesn't coat all the way to the middle, that's fine. The way I imagine it, it's going to give it a nice cocoon of strength.
After the penetrating epoxy cured, the fence had a noticeably harder surface, and I was able to finish squaring the front and bottom faces to each other on the joiner. The drawback at this point was that the channels for my T-tracks were now too shallow, but that was easy to fix at the router table. And if you want to build this fence without a CNC machine, this might just be the best way to cut these channels in the first place.
Alright guys, so we ran into just a little bit of an issue. Now with those two dowels running through the ends here, this whole thing is really quite strong. There's not much of a way that I could break the MDF with any flex in it. That is, except for I had the 3 sections in the original glue up, and at this chunk right here where there is a gap in that dowel, it tried to start splitting apart. You could see a crack in that MDF all the way around. It actually happened twice. I fixed it once, didn't bother to tell you because I didn't think it was a big deal. Then it happened again and I thought, let's fix this. So my solution is, at a 45 degree, I ran just a single saw blade kerf through the table saw down that kind of meaty part of that corner, because it doesn't interact with any other parts of this thing except for that. And now I'm just going to glue in this little oak strip, basically a very long spline, and that's going to add a lot of strength to this, hopefully keep it from trying to split anymore.
I cut some tabs that would fill the voids in the front of the fence and drilled elongated holes to mount the fence to the saw with a little room for left to right adjustment. With the fence bolted in place, I could test the left to right movement of the saw and mark where the fence interferes with the overall range of motion. I used a trim router to cut away some of the material, being really careful not to cut into the voids on the inside of the fence. This made it so the saw gained a few extra degrees of rotation. I wanted to replace the throat plate in my saw while I was at it, and of course only unnecessary walnut would do the trick. I cut a piece to width and used my drum sander to get it to the correct thickness. To get the correct radius on the ends, I screwed the original throat plate pieces to the board, roughly cut them on the bandsaw, then flushed it up on my belt sander. This technique had the added benefit of showing me exactly where the mounting holes needed to be drilled. I cut a small triangular notch in the back end of the throat plate that would be hidden under the fence. I drilled a corresponding hole in the bottom of the fence that would line up with that notch, allowing the dust collector to pull air through the zero clearance kerf in the throat plate. Finally, it's all done being built, but I didn't like the shabby look of the MDF on my saw, so I took time to mask off the fence and use spray paint to match the fence to the saw colors the best that I could.
Well guys, that is my entry into the overly complicated solutions for the miter saw dust collection conundrum. It was a lot of fun to try to think a little bit more outside the box and come up with something that I hadn't seen before. I don't want to claim that it's actually going to work better than anybody else's. I haven't tested it as thoroughly as Drew tested his, but from what I've seen so far, I would think that Drew's is a little bit more effective in the just perfect 90 direction, because his stands taller than mine. And what I've noticed with this is that with the upturn of the blade on the back side, it's actually trying to throw dust over the top of my fence. So when I incorporated the T that ties off and actually applies suction to the built-in sort of dust collection chute, that's when mine starts to really work well. But then again, what it also does well is it bevels left and right, and it allows you to lean it left and right too, so you can get miters and you can get bevels without having to take the fence off. The range of motion is still really good. It's not quite 100%, but I can do about 50 degrees to this side and about 52 degrees to that side. With it being MDF, I can continue to just cut into this at whatever angle I need. It hurts my feelings a little bit every time I mark up that face, but that's the whole point, is that I can cut into this and do the angles that I need to do. I want to thank Drew for kind of being the inspiration for this whole project. It was a lot of fun. I also need to thank Inventables for supporting me with this project. You saw I used the CNC machine, and it was a huge help and a huge time saver to me. A little bit of work in the computer translated into a lot of saved time here in the shop. But that being said, I do have plans available that have templates so that you could cut these out yourself using more regular tools. So that'll be linked down in the description. That really ought to be about it. Thank you guys for checking this one out. Let me know what you think. Is this a dumb idea? Is it got potential? I feel like it has potential. It was fun regardless. Coming up, I will be making a miter saw stand that goes against this wall over here so I can get rid of the radial arm saw and kind of the junky workbench that I have over there. So stay tuned for that. I've got a lot of other stuff coming up, and yeah, thanks for watching.